Hello everyone, welcome back to Pseudotech, and today we're going to be doing math homework in LaTeX. I'm sure the viewership of this video just went down as soon as I said math homework, but stick with me for a little bit because this might be interesting or helpful depending on what you're doing. Now, this is not going to be a full video covering LaTeX, but it's going to be specifically how I do my math homework in it, so it's kind of geared toward this specific case scenario and how I do the formatting and do the equations and everything like that. So, to begin, LaTeX is a text setting language that is in results similar to Google Docs or Word, but in practice significantly different and a lot more powerful in most scenarios. So you can do everything from changing your margins to your font size to what you have in the document. But in general, it goes into a lot more depth and is often used by publishers and people that want to write math equations like this, where it looks really nice. I mean, like, look at those integral signs. They're just perfect. So to begin, we're going to be starting with a very basic sheet that just says hello world, and this is pretty much the most basic LaTeX thing you can have. Up here we have our document class, which tells us the size of paper, the size of the font, and then the article format. I use the article format, this scenario can be used with a couple different formats. You can look them up online. Again, I'm not going to be going into too much detail on the things that aren't really relevant to this video. And then down here we have everything that's going to appear in our document. So before we go ahead and start editing this, I'm going to show you what our finished product is, which I just had up a moment ago. It's just a basic 2-page math homework with 4 problems. The problems, you don't really have to worry about the math. It's just some kind of basic stuff to get an idea of how to typeset a lot of these different functions. We've got the quadratic function here to show some more complex equations. We drew a graph with PGF plots. We're going to be learning how to do that. And then down here I just have some basic vector calculus to show how to do the little hats and the little vector notation and things like that. The first 2 are just an integral to show you how to do integral signs and the like, and then we have some basic sums. So with that out of the way, let's go ahead and get started. The document that we're working on right now is mathhomework-homework.pdf or -tech. And I'm currently working in Atom, which is just kind of my favorite code editor. So you can go ahead and use Atom. You do need the backend for LaTeX to work. It's pretty simple to install, but you're going to need that backend before you start doing it with other applications. So before we begin editing the document, we're going to add a bunch of stuff to the header up here. So let's go ahead and make some space. The first selection of commands that I'm going to use are going to be use package, which is just literally use package. And this is to import different packages. So the first package that we want is geometry. And this is going to basically let us to set the margins to not an unreasonable 2 inches or something that it has by default, so we can not use so much paper. And this has a required argument which is the geometry, and then an optional argument which is in the straight brackets. And the optional argument that we're going to use is the margin, because we want to set that, and we're going to equal that to 1 inch. Then we have a couple of packages that we just want to import, but we're not going to do anything with quite yet, and that's use package AMS math. We have AMS symbols. We have fancy HDR, which we're going to use. It's fancy headers. Oops, I want to use package actually. We're going to use that in just a moment to set up our headers, and then we want to use PGF plots. Now PGF plots is what we're going to be using for the graphing. Again, not all of these packages are necessary for all of the homework that you're going to do, but I use kind of the same template and I just put them all in anyway to have them available. For PGF plots, we want to do PGF plot set, and then compat is equal to 1.16. That's just to fix some compatibility issues that you can have with older versions. I'm pretty sure this is just the latest. And then we can go ahead and start doing our basic header commands to set up other aspects of the document. So although we're not going to be creating a title for this, I still like to put in the author and the title of the document. And then we're going to go ahead and set up our headers. So first we want to do the page style to fancy, and this is going to be basically enable the fancy header package. And then by default, the fancy headers have these lines on the top of the bottom, and if you like that, that's okay. I don't like it, so we're going to do renew command, and then in here we're going to do head rule width, and then follow that up by 0 points, and that's basically just going to make the lines on the top and the bottom invisible. And we have to do that for the head rule width and then also the foot rule width. And then we can go ahead and set up the actual headers that we want. So first we're going to do fancy HF, and that's basically going to clear the headers that are enabled by default, and then we're going to make the custom ones. So our head is the command that we want to use for what we're going to put in the header. And in here you can put anything. I generally just put my name, the TA, and the section number. So in this case we're going to do sudo tech. We can say our TA is YouTube because why not? And then section we can just do 1, 2, 3. Pretty basic. And then for the foot, we're going to do a similar command, which is our foot. And in this case, I usually like to do the page number as I showed over here, but I like to have it say page 1 as opposed to just 1. And if you do /the page, oops, not therefore, it'll just give you the number, so you have to put the page in there manually. There you go. So now if we go ahead and compile this, you can see that I made a slight mistake, and we have to put these 2 dashes on the ends of here to do line breaks. So we're going to edit that and recompile it really quickly. There we go. So now we can see we have that nice header up here. Here we still have the hello world, which is in the main document, and then at the very bottom we have page 1. Now this header and this page 1 would continue for all documents. Let's go ahead and demonstrate that real quick. So if we do new page down here and then save it. Okay, so now we have 2 pages, and you can see that there's page 2 there, and we have the header repeating up here. The headers and the footer are they're out of the margins, that is 1 inch. So depending on what printer you're using, that could be an issue. You might want to adjust that slightly also, but for my printers, it's been perfectly fine. So we're going to go ahead and delete this again, and I'll just recompile it so it's simpler. So in the begin document section, I just go ahead and start writing the problems here. So the way I do my problems is make them each a paragraph. And this is like more or less what the paragraph is intended to be, but basically what the paragraph thing does is it starts a new block of text, and then here it puts this header in bold. And I find you could format it, to specifically just put it in bold, but I find that this works out pretty well. And then I like to indent my paragraphs. It's not technically necessary, but it helps me read it. And then I always put my questions in italics. So we can do text it, which is going to put it in italics. And then within the italics, depending on what your problem is, you may or may not have, like an A section or a B section. And in that case, I always do it as a capital letter in bold. Obviously, you can change this depending on what you want your homework to look like, but this is what I find works best for me. So this is section A, and for section A, we're going to find the sum of 34 and 126 using a calculator. And if we go ahead and render this, you can see that it has the homework number, or the problem number here, which is 1.1 in bold. Then there's a little bit of a space because the paragraph automatically puts that in. And then we have the text boldface, which is A, and that's right there. It's still in italics since it's still within these brackets. And then all in italics, we have find the sum of yada, yada, yada. So if we want to do section B, we could do that down here, but I like to solve the problem in the space directly below it and then start doing section B afterwards. So I create another text in italics and do that, and then I would write the text BF. That's one of the nice things about LaTeX if you're writing your math homework in it, is that you can move stuff around and space is never really an issue where you have not enough space to solve a problem, because you can just move it down, and that's all on a computer, which is very convenient. So section B that we're going to be solving today is find the same sum using long addition. Can save that, and we'll solve these later. And as you can see here, we've got the A and the B section. Now, if we were to write text in here, or if we were to write a math equation, so I'll just go ahead and write that right now. So 34 is equal to 126, because everyone knows that that's correct. Then it would automatically space the B down, as you'll see in just a moment. There we go. So we have this display type math right here, and it's automatically pushing the B down. So as I said before, space is not really an issue. So this is kind of the basic format I use for all of my problems and displaying them, and I would copy them out of the textbook or copy them off from online here. It takes a little bit of time to copy them over, but it's worth it because then you have it all in one document, which is quite nice. So now we're going to move on to doing a little bit of actual math homework. So we're going to start working on these in order, and again, you don't really have to worry about the math involved, just kind of the notation that I'm going to be using. So the first thing is that when the dollar signs are probably the easiest way to do the math. Now, technically, you are supposed to do like its begin equation, and you could do that, and it basically has the same effect. You can look into that syntax in a little bit more detail online. I still use the dollar signs because they're just really easy to write and they're faster, and they work just fine for me. So first we're finding the sum of 34 and 126. We don't even really need a calculator for that, but we can write 34 and 126 is equal to 160. And since this is in the display math format, it's going to center it on the page and have it take up its own line. Now, if we wanted to not have the display math format, so for example, in this case, the 34 and 126, it might make sense to have those be math also. So we can surround those by these single dollar signs, and that's going to be inline math format. If we go ahead and save that and let it compile, which will take a little bit depending on the speed of your computer, you can see that suddenly these aren't italicized anymore, and instead they're kind of regular face math, which for the numbers works. It actually does italicize any letters. So if you have like an X, it looks like, the little math X that's kind of slanted. But that's basically the difference between inline and display. One is when you're trying to show just a block of equations, and one is when it's within text or a sentence or something like that. So that was fairly basic. We can also do the sum using long addition, and the actual process mathematically is kind of the same as what we just did in our head, fairly simple. But if we want to display that, it becomes a little bit more complex. So I'm showing this not just for long addition or something like this, but you can actually also use it for polynomial addition, and then also if you're doing, like if you're solving a system of equations where you want to subtract one equation from the other to solve for a certain variable, then this becomes helpful to display that and communicate that, because ultimately the math homework is all about communicating it to your professor or whatever. So first we're going to do begin center, and this is kind of the same effect as we had over here. And then we're going to begin the tabular. And this is basically going to create a table. And for this tag, we want to add this other variable, which is basically how many, you're going to put the number of C's as how many lines you want. So, or the number of C's for how many columns you want, and then the number of rows is just dictated on how many enters you have or how many lines you have within the sequence. The basic format for this is that we're going to add and symbols to do different columns. We're going to need a little bit of space up here to carry digits over. And then in general, we want 3 on each line and then an enter. And then this one's going to have a plus sign over here, because this is where we're going to put the little plus sign, and we're going to do each line. And now it looks really complicated, but it'll be simpler once we start adding stuff in. So we have 3 and symbols because we have 4 columns, so they're separating each one of those. So then in our bottom row, our number is going to be 126. We can put that in nice and easily like that. And then in our second to top row, it's going to be 34. There we go. And then I like to align these a little bit so that it's easier to see. And so see, that's kind of coming together here. And then this very top row is, we're going to align it, but it's really just so that we can carry digits later on. Let's go ahead and align the bottom row too, so it actually looks decent. So now you can see where they follow through, kind of. So we can add 4 and 6, which equals 0, and then we're going to carry the 1. So the 1 goes up here then, so that we can demonstrate that. And then we're going to add 3 and 2 and 1, which equals 6, I think. align that again. And then 1 just equals 1. So you can see we have the same result, but now if we render it, it'll show it all in a table nicely over here. There we go. So we have the 4, 6, 0, carry the 1, 3 plus 2 plus 1 is equal to 6, and then we drop the 1 down because we're adding nothing to it. So this is kind of what I found to be the best way of doing long addition. Now there are packages that allow you to set this up specifically. I haven't actually gone into this too much, but they might be more helpful than this because this is kind of a pain. But for the amount that I do, like polynomial addition and stuff like this works out just fine, and it's pretty simple once you get the hang of it and make sure to align your columns correctly. There's one thing that I'd like to mention for actually in part A again of this problem, and that is if you want to put a box around your things, then you can do frame box and then to like that, and frame box basically puts a box around it if you like putting a box around your answers, or if your TA wants that. Mine did. And the frame box kind of cancels the current math that you're in for some reason. So you want to put the dollar signs in it again. It won't cancel, like this will still be centered since the display format is still centered. But you're going to have to put the dollar signs around, especially if you use, variables or math symbols inside of it. There we go. So now we have 160 boxed. So now we're going to start working on some other math problems that are a little bit more complex than just basic addition. So the first one that we have is to evaluate the definite integral. And this is basically an excuse to show you how to write integrals in LaTeX. If you were unaware, we're going to be using the U substitution method for evaluating this. So we want to get rid of whatever's under the square root because that looks hard to evaluate. So we're going to do u is equal to x squared plus 4, and then that would make du is just the derivative of that, so that's just 2x. And wow, conveniently, almost like I did this on purpose, that ends up canceling out the 2x in there. So these are going to be on the same line because they're in the same math display format, so I like to do a quad in between. And a quad you can basically think of it as a tab, but the tab character is a little bit funky. And it puts this nice little space in them so they don't run into each other. Otherwise, they would run into each other and it would act as if they're the exact same equation on the same line, which is not what we want in this case, but sometimes is what we want. And then we can start a new line. And I like to begin things with the right arrow quad. So this is the right arrow. Now, if you do right arrow without the capitalized R, it just does the single line, so it's just literally a right arrow. The large right arrow is like a chalkboard kind of script. So for here, we're going to do the integral, and integral is just int, and then we're going to specify the limits. If you didn't have limits, you would just leave it as int for an indefinite integral. And here we want to do the lower bound is going to be 0, but plugged into u. So if we want to be really clear, if we don't want to be really clear, we could just evaluate that to 4. But I'm going to do 0 squared plus 4 just to make it clear that we're applying the u substitution method. Doing it like that. And then next one is 3 squared plus 4. And you can see we put them in these curly brackets. This is the symbol for like a subscript, and this is the symbol for a superscript. Now, one thing I want to mention here that isn't necessarily as we're doing it, but could be helpful if you're not in the math display mode, so if you're doing something inline, is that although in math display mode, the subscripts and superscripts automatically put them at the very top and bottom of the integral, if we want to do it not in display mode, we do have to do the limits, and that would force it to be at the top and bottom. In the integral, this isn't a big deal, but in the sums, actually, if you do like a sum character, if it's in the inline mode, it'll end up being like to the side of the sum character, whereas putting in limits before it will allow it to be actually on the top and the bottom, which is a lot nicer looking in my opinion, so you might want that. So now that we've done our integral, the integral is basically the square root of u du, and I went ahead and forgot the du here because I'm stupid. There we go. Wait, dx. Okay, so basically, if we do the u substitution, we get the square root of u du by putting in there when it finally renders. Looks pretty nice. And then we can say that we can start to evaluate that. So this is equal to The fraction, which is just frac, and then the denominator, the numerator and denominator in the first and second curly bracket sequences that come up. And then we're going to do u to the, and then we're going to do negative frac because it's to the negative 1/2. When we take the antiderivative of this. And then to do the lines that we usually see that say that we're evaluating at these limits, we can do right, and then put in just like a line there, and then we can do the numerator, the subscript and the superscript again to specify that. So this is 4 and then a 3. Again, we're just evaluating the top and the bottom of the integral. Now, this is all that's going to show, but we do actually need to put in a left thing, and we're just going to do left dot. And the reason behind this is that whenever you use the right and the left tags, it's basically going to look at what's in between those tags and their height, and then set the height of whatever the character is to equal those. So this can be really helpful if you want to do brackets that span, like a large fraction or something that's a little bit taller than the usual, bracket height in text. And it'll automatically elongate it to fit that. The dot or the period basically shows nothing, and it's basically just like the left is the end, and then, or the left is the beginning, and then the right is the end, so it knows that we're talking about this section. So we do need that left and we do need that right to be together, but if we just want the right one in this case, then we can put a dot on the left one. So we can go ahead and evaluate these. This is frac again, 1/2, and then I'm just going to put the square root of, it should be 13 actually, not 3. I'm going to put 13 there because 3 cubed plus 3 squared plus 4 is 13. So we're going to do that, and then minus the initial one, which again is going to be another fraction. So frac 1/2, and in this case it's square root of 4. And then I'm going to go ahead and plug this into the calculator. But basically this approximates to negative 0.1113, and then there's a bunch of decimals after that, so we're going to use the /approx symbol to show that it's not absolutely equal to that, but we can do a frame box again to show our answer, which is kind of nice. Now we can see that subtracting those two fractions equals 0.1113, roughly, with the approx sign. Our next problem is a basic quadratic equation, so we're going to go ahead and start right with that. It's a fairly basic quadratic equation as far as they go, so it's just y is equal to x squared plus 2x minus 3, and we're going to try to find the roots of that equation. So we can see that x is equal to the fraction of, I'm just going to write it out first, so negative b, and then for plus or minus we do /pm, and then slash square root of b squared minus 4ac, negative b plus or minus square root of b squared minus 4ac divided by 2a. I think that's the quadratic equation. So x equals negative b plus or minus square root of b squared minus 4ac. And as you can see, that was pretty simple to write this somewhat complex equation with fractions and a square root and a plus or minus sign. Could probably write it faster by hand, but it would not look that nice, I can guarantee that much. So now we can fill in our variables. So fraction again, so it's -2 / plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is -3, and then divided by 2 times 1. Go ahead and write this again. So fraction, for simplifying it, is equal to -2 / plus or minus / square root of 16 divided by 2, because that's not a square root. Let's fix that. Okay, so that's 4 plus 12, which is equal to 16 indeed. Let's go ahead and render this very quickly. There we go. So we have this kind of series of equations here that are getting simpler and simpler. And we can go ahead and factor out 4 from that square root and then divide all of them by 2. And we get that x is equal to 1. And for this, we're going to do the quads again so that it doesn't scrunch it all together. And for the and symbol, for some of the symbols, including the and symbol, if you want the actual thing, you do have to do /and so that it differentiates it from a command, and then -3. So now we're going to graph those points to verify it. So to do graphing, we do need that PDF plots package that we imported all the way up here. To use it is a little bit complex, but because it depends a lot on what you want your output to be. So in this situation, we're going to add a very basic quadratic equation plot and then add plot like markers to plot the coordinates of them. But you can also do very complex things with this. Last week I used it to plot different points and then try to approximate a curve in between them, as opposed to plotting the actual function of the graph, just like from 5 different points that I put in. You can do 3-dimensional curves with this. You can do, parametric equations, although those get they're kind of a pain in the neck with this, so I'd recommend just doing it in like Python or something like that. But for this, we're going to keep it simple. So we're going to do begin center again. And within that, we're going to begin a TXIE picture. And TXIE is kind of the fundamental thing that runs the equations, and then PGF plots makes it a little bit more accessible. And then we're going to begin the axis, which is part of PGF plots. And the axis has a bunch of variables that we can describe up here in this little optional metric section. So we can do x label. We're going to just set that to equal to x, because that makes a lot of sense. End it with a comma. Y label is going to be equal to y, because that makes a lot of sense also. And then we can set the bounds. So I'm going to set our x minimum. I happen to have done this before in getting prepared for this video. So we're going to set that to x min is -4, x max is equal to 2, y min is equal to -5, and y max is equal to 2. So that's going to give us a pretty nice viewing window for this particular equation, but obviously you should adjust it based on, what kind of bounds your equation has. Then we can go ahead and add the plot for our function, which is x squared plus 2x, and for here we have to do 2 times x. We do have to specify that times symbol, -3. And we end it with a semicolon. And this is all y is equal to that. We're not doing parametric in this situation. If we go ahead and render that, we should see our function graphed pretty nicely like that. As you can see, it automatically puts some points in. There are ways to get rid of the points or add more points if you want to, change the shape, the color, whatever you want. But I'll let you look that up by yourself. But basically, that's kind of the most basic graph we can get. Now, if we want to label those points, we can kind of estimate that it's around here and around here at 1 and -3. But to verify them, we can plot 1, 0, and -3, 0 to verify that it is in fact on the line. So we're going to do add plot again, and this one's a little bit more complex. So we're going to set our mark is equal to an asterisk, and that's just going to make them dots. We want these to be red to differentiate them from the blue the blue dots, and then we're going to do only marks, which is basically going to prevent it from creating a line in between them, which is not what we want in this situation. So we're going to plot the coordinates. There we go. And our 2 coordinates are 1, 0, and -3, 0. We have our plots here, all nicely marked in red. And as you can see, they are in fact on the line, so our quadratic equation was successful. All right, so our final problem, basically I'm trying to demonstrate how to do the vectors and stuff like that, and the hats. So we have a particle's location at t equals 0 is 147. And then it has a given velocity. So we want to find the particle's location at as a function of time and then evaluate it for t is equal to 6. So mathematically what we're going to do is integrate every component of the velocity vector, or the velocity function, and over a period of time to get the location as a function of time, and then we're going to evaluate it for t is equal to 6. So I've already done that because it's a little bit complicated. It's not that complicated, but I don't feel like going over it in the video. So the first section is to figure out as a function of time, and for that we just basically do what I'm pasting in here. So basically here we integrate it, and then we set the c is equal to the original point, because when you set it to equal to 0, they all cancel out. And then we can do a frame box again to write out our entire answer. So we're going to do begin center to make sure it's centered, and then frame box. And again, we have to add the $signs. And here, we're basically going to copy what's up here, but then enter the c's. So we have that ci is equal to 1, cj is equal to 4, and ck is equal to 7. For part B, which we can mark with the text bf, just b, not bf, for that we're going to want to do, we can basically evaluate it just in our head, so, or with a calculator. So we can just do text center again and then make another frame box. There we go. And then for this, we're going to write the same thing, but as a function of 6, or as 6 is equal to t, because we want to evaluate it at that point in time. So we can do vec, which is the vector notation, which I'm sure you've already figured out already, of r, so the displacement is, at 6 is equal to, and then we're basically going to evaluate this function here. So this equals 91, and then hat is just what we use to get the unit vector of I, and then plus 40 hat j, and then finally plus 121 hat k. I haven't actually checked my math here, so I'm hoping this is correct. But the point is not the math. The point is how you write the math in LaTeX. So part B, this is the position as a function of time at t is equal to 6. And that's about it. So that's all of our equations that we're going to, or our math problems that we're going to be doing for this homework. But I hope this video was somewhat helpful in explaining how to write your own homework in LaTeX. Hopefully you got some techniques or something like that. There are plenty of videos on just LaTeX in general and how to typeset using it to write papers and stuff like that on YouTube and other places on the good old interwebs. But hopefully this little technique has been helpful for you. Anyway, if you have any questions, leave them down in the comments below. Otherwise, thank you for watching, and I'll see you in the next video.